binomials, that's a vocab term that you're going to need to remember. So remember binomials, the prefix bi means two. So a binomial is something that has two terms. So in A, x plus 3 is a binomial, x minus 5 is a binomial. So review multiplying binomials. Your Algebra 1 teacher has probably taught you FOIL, first, outer, inner, last. Personally, I hate the word FOIL. I think it's a four-letter F word. So if you ever need to use an F word, you can use FOIL in place of whatever other word you were planning on using, and it'll mean the same thing in my head. Because if you get something like a binomial multiplied by a trinomial, FOIL no longer works for you. So FOIL is a trick that only works when you're multiplying binomials, and for that reason, I don't like it, because I don't like tricks. So really what FOIL is doing is it's tricking your brain into using the distributive property more than once. So when you're multiplying binomials, take this x and distribute it to the second set of parentheses. X times x is x squared. X times negative 5 is negative 5x. Then distribute the 3 to both of the terms. 3 times x is 3x, and 3 times negative 5 is negative 15. Really, what you just did was first, outer, inner, last. We just didn't think of it as FOIL. We thought of it more like double distribution. Use the distributive property however many times you need to. Then combine your like terms in the middle. We have x squared minus 2x minus 15. Now before we move on, this is often referred to as expanded form. If someone says expand the polynomials, what they're saying is multiply this out. When it's written as two binomials, this is called factored form. And what we're actually going to be doing today is starting with expanded form and going backwards and factoring. Take a look at this expanded form. Take a look at the number -2 in front of the x and the -15 at the end. And now go back to the factored form. See, in the factored form, there's 3 and -5. I want you to see if you notice anything about the 3 and the -5 and how maybe those two numbers are related to this -2 and the -15. Let's start first with the -15. Think about 3 and -5. How are 3 and -5 related to -15? 3 times -5 is -15. -15 is the result of multiplying the 3 and the -5. Now let's look at the -2. How's -2 related to 3 and -5? It's the sum of 3 and -5. If you add 3 and -5 together, you get -2. So if we wanted to do this problem backwards, all we'd have to do is figure out what numbers multiply to give us -15 and add up to -2. Once you figure out it's 3 and -5, you can write it in the factored form. That's what we're going to do today. We're going to skip B because we don't need to do it right now. C, whoops. Let's start by distributing with the parentheses. It's kind of like we're going to do this part first. So x times x is x squared. X times -3. -4 times x. -4 times -3. Before we distribute the 2, I want you to think again about those numbers. Originally, we had -4 and -3 in the parentheses. Add -3 and -4, you get -7. Multiply -3 and -4, and you get +12. So I want you to start seeing those connections because that's going to help you when we go backwards and have to factor. When we multiply the 2 in, we would end up with 2x squared minus 14x plus 24. Okay. Factoring. There's some directions up here that we're going to skip, and I'll reference back to them in a minute. Basically, what we're doing, remember that the 6 is the result of multiplying two numbers together. The 5 is the result of adding two numbers together. So some of you are probably very visual people. I like to do this with visual people. Blank times blank equals 6. Blank plus blank equals 5. Now we need to come up with the pair of numbers that satisfies both of these situations. And some of you, especially with the small numbers, you're going to look at this and just bam, you're going to know exactly what number it is. Some of you might stare at these blanks for a while and have to really think about it. That is totally okay. So 2 times 3 is 6. 2 plus 3 is also 5. That means the factored form is x plus 2, x plus 3. Could you also write this as x plus 3, x plus 2? Yes. The order that you write the binomials does not matter as long as one of the binomials is x plus 2 and the other binomial is x plus 3. So you're looking for the two numbers whose product is the c value. If you think of this as standard form, ax squared plus bx plus c, you're looking for the two numbers whose product is c and whose sum is b. So we want two numbers that multiply to give us positive 36 and add up to negative 12. And if you immediately know what those numbers are, good job. Your brain processes things in a very efficient way. Some of us, me included, our brains don't process things quite that efficiently, and there's nothing wrong with that. So you might need to make a list of ways that you can multiply to get 36 in order for your brain to see which pair of numbers this is. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. We can probably get negative 12 using 6 and 6. How do we get negative 12 from 6 and 6? And negative 6 times negative 6 is still positive 36. So x minus 6, x minus 6. Okay? What these directions are saying up here, when c is positive, like in both of these examples, both signs are going to be the same. They're either both going to be plus, like in number 1, or they're both going to be minus, like in number 2. Now, do you notice anything else about number 2, about that answer? They are exactly the same, so you can rewrite it as x minus 6 squared. When the two binomials are exactly the same, you can write it as one of those binomials squared. Give number 3 a try on your own. If you need help getting started, you're looking for two numbers that multiply to get 84. Those same two numbers have to add up to 19. If you're making a list of pairs, try to be systematic about it, like I did in this list, going from 1 to whatever. Once we do this, I think 7 and 12 could give us 19. 7 plus 12 is 19, and 7 times 12 is 84. It is important to note, you have to have the same pair of numbers. You can't use two different pairs of numbers. That kind of defeats the purpose. So because our numbers are 7 and 12, our factored form is x plus 7, x plus 12. Okay, in example 4, now we're going to deal with what if our c value is negative. If our c value is negative, that means that the two numbers in the binomial, the two signs in the binomials need to be different. But we're going to treat this the same way. So we need two numbers that multiply to give us negative 18 and add up to negative 7. Hopefully with 18 it's a little bit easier. How could we get negative 7 from one of those pairs of numbers? Negative 9 plus 2. Hint, if you want to add up to a negative number, the bigger number needs to be negative. If you want to add to a positive number, the bigger number needs to be positive. So our factored form is x plus 2, x minus 9. Okay, how many more examples do we have? Do we need to do number 5, or do you guys feel pretty good about this? Let's do number 6, and then we'll talk about 7 and 8. So try number 6 on your own. To get negative 12 using addition, you would do 2 and negative 14. So our factored form, x plus 2 because it's positive 2, x minus 14 because it's negative 14. Okay, number 7 is kind of a unique case. Do you notice that there's no b? There's no x term. So this is really x squared plus 0x minus 49. So if we use this same philosophy, we are looking for two numbers that multiply to give us negative 49, but at the same time, they must add together to get 0. If you're adding to get 0, it must be a positive negative of the same number. So what number times itself is 49? 7. So positive 7 and negative 7. Our factored form is x plus 7, x minus 7. Now that's a whole lot of work to show to get that factored form. Is there maybe a shortcut? There is. If you see two numbers, or two terms, subtracted, x squared minus something, there's a really good chance it's the difference of two squares. Are you familiar with your perfect squares? 5, 6, 7, 8, 9, 10, 11, 12. These are your perfect squares, 1 squared through 12 squared. If you see these numbers in factoring problems, it should be a little like red flag in your brain that, hey, there might be a shortcut here. So if you see x squared minus one of these numbers, the shortcut is x plus the square root, x minus the square root. So take a look at number 8. 64 is one of these perfect squares. What is 64 the perfect square of? 8. So our factored form is x plus 8, x minus 8. If you can recognize that x squared is a perfect square, 64 is a perfect square, you can quickly get your factored form without doing a lot of work. The trick is if you've got a perfect square, like a squared, minus a perfect square like b squared, the factored form is a plus b, a minus b. If you don't have a c term, you're going to be factoring out the greatest common factor. So let's think about x squared and 5x. What do x squared and 5x have in common? X squared and 5x. They have x in common. Basically, factoring out the greatest common factor is like undoing the distributive property. So you're finding something that they have in common that you could divide out of both of them. So I could divide both of these terms by x and put that x right there. X squared divided by x is simply x. 5x divided by x is 5. Now if you use the distributive property again, x times x is x squared, x times 5 is 5x. We're just undoing the distributive property. So try number 10 on your own. They have 2x in common, so it's like you're dividing both terms by 2x. 2x squared divided by 2x will simply be x. Negative 12x divided by 2x. The negative 12 divided by 2 is negative 6, and that x will cancel itself out.